All right, so I'm going to quickly review the 4 that we have learned so far. I'm not going to actually construct them. I'm just going to show you what they look like in their properties. So the very first one we did was a perpendicular bisector of the side of a triangle. So we did our arc up above, arc down below, arc up above, arc down below, X marks the spot, X marks the spot. And what that did, it looked something kind of like this. It was perpendicular, and it bisected the side. We're just reviewing, so we can kind of remember what we've done so far. That was the first day. Also the first day, we did an angle bisector, and what does that do? What does an angle bisector do? Yeah, it bisects or cuts exactly in half one of the angles, which means how many times could we do it? 3 times. But if I took this angle and I bisected it, it might look something like that. And that means that these two are congruent. Now notice, they don't necessarily go to the same spot, right? It just depends on the triangle, okay? That was all the first day. Last class, we learned something called a midsegment and a median. So the midsegment goes from what to what? What point? What type of point? A midpoint. A midsegment goes from midpoint to midpoint. Mid. So you have to find 2 midpoints. And I actually already know this one, right? Because that's the perpendicular bisector, which means this here is the midpoint. So midpoint, and then you would find another midpoint. So let's say this is the middle. And then you just connect 2 midpoints.
Would the angle bisector, where it goes and hits that line up there, would that be the midpoint?
Not necessarily. In that case, it would be because it looks like it's an isosceles triangle, but not if it's a scalene triangle. So be careful. What 2 things did we learn about that green segment we call the midsegment? There's 2 things that you should remember with one of them. It is half of the side it's not touching, and what does it look like? It's parallel. So remember, it would be this side would be parallel to this side. So I can put a couple arrows on there. And if this was 8, what was the midsegment? 4, half of it. Good. And then the other one we did last class, and we also warmed up today, was our median. And you just did it 3 times on your patty paper. Where does a median start? Midpoint. And then it goes to where? The opposite side. Vertex angle. Yeah. So we'd find a midpoint, and then you would extend that to the opposite angle. And the 3 medians are concurrent at the centroid. That's that center of gravity one. So the 3 medians make the centroid. Okay? So that's everything we've learned so far. We good there? Okay, our last one we have to do is called an altitude. So find that real quick on your notes. Find the altitude. Now that diagram looks kind of confusing. That's okay. I'll show you it here in a second. But basically, the altitude, what do you think of when you hear the word altitude?
High.
What? How high something is, right? Like if you're in an airplane and you're at a certain altitude, that's how high off the ground you are, right? What about the altitude of a mountain? Yeah, how tall the mountain is. Which is kind of nice because triangles are kind of mountain-esque shaped, right? So let's take a look at these 3 triangles here. And we want to draw one of the altitudes. Once again, there could be 3 of them. But let's draw the most obvious one. So look at the triangle on the top. How could I draw a line so that that line shows how tall that triangle is? Emma, what do you think?
Wouldn't it be from the point, like, straight down? Right?
Which point?
The top.
The top vertex?
Yeah, to like the bottom vertex.
To the bottom vertex. So what could we say about this altitude? It's a 90-degree angle, and it's actually, it's one of the sides, right? The altitude was actually one of the sides, because this would be the height of that triangle, right? Like if I asked you, how tall is that mountain, you'd get a measuring tape, a really long measuring tape, and you'd go up the mountain, and that's how tall it is, okay? Now, we could turn it, and there's 3 ways we could do an altitude. So if I take this triangle, and I give it a little rotate, let's say this is the way the triangle is facing now. Where would I have to draw my line so that it would represent how tall the mountain is, Parker?
You draw from the top vertex down down to the middle of the bottom one.
Good. It would be the top vertex straight down to.
We have to make a midpoint.
Yeah. Now, in this case, if it was an isosceles triangle, then that would be another midpoint. But we don't necessarily know. So, but yeah, it would be more. It would be straight down the middle, and the altitude is always perpendicular, kind of like a perpendicular bisector. In fact, in this case, it is a perpendicular bisector, right? So sometimes the altitude can be a perpendicular bisector. Not always, but it can be. So hopefully you drew that on your triangle. Now let's look at this one on the bottom left. Where would I have to draw a line, whereas that is representing the height of this mountain? The left side, how? Outside, that's correct. So if we have, here's the top of the mountain, right? Straight down would be the height of that triangle. It is always a 90-degree angle. It's straight up and down. So if I ask you how tall is this mountain, you'd have to come over here and measure straight down. So sometimes the altitude is actually on the outside of the triangle. Why is this not the altitude?
Slope.
Yeah, that's not how tall the mountain is. That's like the distance if you're hiking up the side, right? The altitude is straight up and down. How tall is this mountain from the earth? And then the last one here, where would the altitude be drawn? Haley?
From the point to
That top point?
to the to the side, the bottom side.
Straight down to the bottom side. So that right there would be an altitude.
Does it matter which
Do what?
no matter what side that is?
The bottom, usually.
Oh,
That part.
it's like the right, like right or left.
Oh, no. Any questions on how to draw an altitude?
No.
All right.
Yes.